Hi, this is Kevin Trainer, and I'd like to welcome you to my lecture on Chapter 5 of the Murach MySQL book, second edition. And Chapter 5 is entitled How to Insert, Update, and Delete Data. I'm not going to go through the objectives, but you're certainly free to review those on your own. Okay? So, what's going on in the chapter? Well, we've had two chapters, chapters 3 and 4, right before this, in which we were getting the hang of using the select statement to get data out of the database. And of course, since we're more interested in answers from our applications than feeding them data, I think that's completely appropriate. But we can't get data out of the database until we put it in, okay? And perhaps until we maintain it, okay? So this is a chapter on how to get the data into the database, how to change values when they change in the world, and we want the database to agree with the state of things in the world, how to delete data when we're done with it. Okay, so that's what we're doing here. So on slide 3, one of the ways that we can get data into a database is with the create table statement. Okay, and this is an interesting statement, but not one that I would say that I've used a whole lot. Okay, I mean, I've certainly used it some. All right, so the primary way we insert new rows into tables is with the insert statement. However, there are times where we want to create one table from another table, right? Maybe we have a table of invoices and we want to create a table of old invoices or invoice archive or something like that. So this is certainly a use case that we have, but it's not your everyday use case. So here's how we would do it. Create table invoices copy as select all columns from invoices. Or maybe we just want the old invoices. So create table old invoices as select all columns from invoices where, and then we have an expression that indicates that the invoice has been paid. Okay? So that's one of the ways that we can do that. I just want to point out that with just the statement we have so far, we have a copy of the rows that qualified, right? So in the first one, we have a copy of all the rows in the copied table. In the second one, we have a copy of just the rows that qualified, that satisfied the where clause, okay? We haven't done anything to the original rows, okay? Just saying. Okay, here's a case where we might want to create a table with summary rows from the invoices table. Okay, now this is a nice idea, but I want to point out here that as we're going to learn in a chapter real soon, we're able to summarize tables on the fly with queries, okay? So we don't have to hold on to summaries, okay? And there might be a reason, a very good one, in our application why we want to hold on to a summary. Perhaps that we summarize things in a particular way frequently, and we think that it's inefficient to keep summarizing it over and over again. But as soon as we summarize the data and we keep a copy, we've got redundant data on hand, right? So if the underlying data should be supplemented, then the summary is old. Okay, so this is again a use case, but it's not an everyday use case. So how did they do this? Create table vendor balances as select, okay, the vendor ID, the sum of invoice total as sum of invoices from invoices where the invoices are not equal to 0. So that means that they've either been they either haven't been paid yet, or perhaps they've been underpaid, or perhaps they've been overpaid. Okay. Group by vendor ID. Okay. So we're going to learn how to do those summary queries later. Okay. All we're seeing here is you can save the results and create a new table from it. Okay. And I could see that you might want to do that. But again, as soon as you create a summary table, you have in effect duplicate data in the database, and that might go out of date. So let's be careful about how we use this feature. Warning here. Okay, when we use the create table as statement to create a table or a copy of a table, only the column definitions and the data are copied. The definitions for primary keys, foreign keys, indexes, and so on are not included in the table. So when we learn how to define tables ourselves, we'll learn that yes, we have to identify the columns and how they're defined, but we also have all these constraints that we add, and they're what really make the database go in terms of the relationships between tables and this thing we call referential integrity. So we get a copy, but we don't get a copy of everything. Okay? So you have to keep that in mind. Okay. Now let's go to a more common use case. Every time we want to add a row to a table, we do it with an insert. Okay? Well, I'm sorry, we just saw a way to add rows to a table without an insert, but it's not as common of a use case. The most common way to add rows to a table is to insert them into the table. Okay, so here we go. On the slide number 5 here, we have a syntax diagram for the insert statement. Okay, and we have the column definitions for the invoices table, and we have to understand the columns that are in the invoices table to formulate a proper insert statement. Okay? All right, so let's look at some examples. So the top example here, insert a single row without using a column list. Okay, so one of the things that we can do is we can list the columns that we're trying to insert. Okay, well, what if we don't use that? Well, by implication, we're inserting all the columns. So if we only provide a values clause, like we do here, the values have to be presented such that they match up with the columns in the order in which they are listed in the database definition, in the schema for that database, for that table. Okay? However, sometimes there are columns that we don't want to insert. Well, why would that be? Some of our columns have a default value. Okay? So maybe we want to just take the default value. Some of our columns have like a special kind of a default value called auto increment. It's the thing that we do a lot for the ID field, things like vendor ID. Okay, uh, so we give it a definition. We say that it's an integer and it's an auto increment, which means we're not going to provide on a new insert. We're not going to provide the vendor ID. The database server is going to generate the next one. It's going to send it back. Well, in that case, we might not want to provide the vendor ID. So we could want to do an insert on a table in which we had either auto increment columns, columns with default values, or maybe columns that can accept a null entry. And so we would want to have a list of the columns that would be shorter than a list of all the columns that are there. Okay, and if you look in the second example here on the slide, where we are passing in 1, 2, 3, 4, 5, 6 values, whereas when we had to pass them all in, because we didn't have a column list, we passed in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it looks like for one reason or other, 4 of the columns didn't require a value, and we didn't provide them in the second insert that we're showing on this slide. It's possible, as you see here on slide 7, to insert more than one row at a time. A place where you'll see that is if you look at the scripts that we use to load and reload our sample databases that came with the textbook. These scripts were created by essentially taking a backup dump of the database, and they include not only the definitions for the tables and the columns and all of their nice constraints and all that stuff, but they also include the inserts to populate the data into the database. And I think most of those inserts are like this one. They insert more than one row at a time. So here's one where we're inserting more than one row at a time. It looks like we're doing 1, 2, 3 rows. And we're not providing a column list, so we have to provide a value for each of the columns. And the order that we provide them in, if we haven't provided a column list, is the order in which they occur in the definition for the table. Okay. So now we're going to see another table. This is the color sample table. Okay. So let's see. It has 3 columns. It has a color ID column. It can't be null. It's auto-incremented. Color number, it's also another int column, not null. Default 0. Color name, varchar 50, so that's a character column up to 50. So because of the way we coded the first 2, okay, they are in some sense optional columns. Okay, so the server can figure out a value for them even if we don't provide one. If we provide one, well, then that's going to be different. So if you look at our first insert, it only provides one value, 606. Okay, and it's providing it for color number. Okay. Now, what's going to happen here? Well, let's just think about this. Color number is an int. That's fine. We can make that 606. Color ID is auto-incremented, so we don't have to provide that. color name is, it doesn't have a constraint that says that it can't be null, so it can be null. So if we don't provide it, we're going to get a null value for the color name. Perhaps not very useful, but still a legal insert. The second one, we're providing color name and we're giving it the value yellow in characters. So can we do that? Well, yeah, because we don't have to provide the first two. A color ID can be generated from the auto increment. Color number has a default value of 0. So we'll get proper values for the first two, and then we'll get yellow for the third one. Okay, the last one, insert color sample values default orange. Okay, so we don't have a list of columns, so we need to provide a value for each column. The default things say take the default value. Auto increment provides a special default value that keeps getting higher every time we do another insert. Default 0 is going to provide a default value of 0, and of course orange is going to give us a character string orange. So the result there is going to be 0. No, it's going to be whatever the next number is for a new row, 0 orange. Okay, the fourth one, values default 808 null. So default in the first column is going to get the auto incremented value. 808, we're going to have column number 808, and we can provide a null for the color name because there isn't a not null constraint on the column, so that's going to work too. And the very last one, again, no column list, so we have to provide all the values. Default null. Okay, now this isn't very interesting, but again, it's legal again. Default in column 1 will get us the next incremented value. Default in column 2 will get us a 0. And null in column 3 will get us a null. Again, not a very useful row as an entry in the table, but still a legal thing to do. And there you go. Here on slide number 9, here's what those things are going to look like. So this might not be the most useful set of rows that anybody ever inserted into a table, but they were successful because they all met the rules that they had to meet to be proper inserts. Okay, now we have these things called subqueries, and subqueries are very powerful, and we have a whole chapter where we learn about subqueries. Okay, so we should have our interest peaked here. At the same time, we should know that we're going to get more training on this. Okay, so here's the case where you are inserting into a table and you can have a column list, but what you do is you provide a select. So what happens is that the result set that comes back from the select, from the query, those become the insert values to be used for each of the rows that we try to insert. Now that's going to work just fine provided that they're the right kind of values. Okay, so the same kind of rules that we applied a couple of slides ago to the inserts are fine. But if we try to, if we get a result set back that has a null, and then we try to provide that as the data for an insert, and it's not, nulls are not allowed in that column, well, then we're going to get a bad outcome. So the example here, insert into invoice archive, select all the columns from invoices where invoices have been paid. Okay? So how's that different than the create table we had before? Not very different. Just remember that the create table created a new table definition, and this is just using a table definition that we already have. Okay? Apart from that, they're pretty similar statements. Here's the same statement with the column list. Okay? So we listed out all the columns in the insert, and then we listed all the columns explicitly in the select, and then from invoices, and then we have a where that shows that they've been paid. All right. So those are the ways that we get data into tables. Now, there are times we want to update data. Well, what are the use cases for that? Well, two that I can think. One, where we come to understand that the data in the table is wrong. We had some kind of key entry error or something like that. It was never right. We've just made a mistake. Okay? The other is where there's been some kind of change in the world outside, right? And what had been true before is true no longer. So we need to change the value just to keep up with the changing world. In any case, what we want to do is to come up with a new value for one or more of the columns in that row. And when we're done, we're expecting them to agree with the state of affairs in the world that we're trying to represent. Okay, so here is an example of updating two columns for a single row. So we say update invoices, that's the name of the table, set. Now here are the things we're going to change. So we list two columns we want to change. Payment date equals, we give a new value. Payment total equals, we give a new value. Where invoice number equals, and then we give the value. Okay? And provided that we've identified a row successfully with the where clause, we're going to get one row affected, which is going to be the data is going to be changed. Okay, how about if we want to update one column for multiple rows? Okay, and this is a pretty typical thing. I want to emphasize that SQL is not a procedural programming language. Okay, in a procedural programming language, if you wanted to update a bunch of rows and do the same thing to them, you would do something like this. You would you'd fetch a row, you would update it, and then you'd fetch another row, and then you'd update that. Then you'd fetch another row, and then you'd update that. Luckily for us, SQL is more of a language where we describe the results that we want to get. So if in fact we would like to update one column in 6 rows, well, we just have to write the where clause the right way. So here, the top level example, update invoices, set terms ID equal 1 where vendor ID equals 95. 6 rows qualified and 6 rows were affected or updated. And then here's one, the second example on slide number 13, update one column for one row, update invoices, set credit total equal, and then we're going to increase the existing one by 100, where invoice number equals, and then we have that. Okay, so we can affect one, we can affect more than one. I just want to point out that these two examples that we show you on this page are uncomplicated because of the fact that the where clause refers to vendor ID, which is the primary key for that table. Now, on slide number 14, we're going to warn you that in certain cases, you may want to do similar things based upon the values of other columns that are not the primary key. So one of the things that can go wrong when you're doing these multiple row updates is you can get a little too generous in how you code your where expression. And because of that, instead of updating one row, you update all the rows in the table. So, and there could be a lot of rows. I mean, I've taught classes where students are working with the database that have millions of rows. So you wouldn't want to accidentally update 4 million rows. No, you wouldn't. Okay? So what they do is that they have in MySQL, there is a setting in MySQL Workbench in order to keep you from doing that accidentally. Okay? And it's called safe mode. Okay? And here's what it does. By default, Workbench runs in safe update mode. This mode prevents you from updating rows if the where clause is omitted. Okay, so that would automatically just apply to all the rows, or doesn't refer to a primary key or foreign key column. Okay, now if it refers to a primary key column, because those have to be unique, you're probably going to match just one row. And the foreign key, you're probably going to match one or at most a couple. Okay? But there will be times, and perhaps when you're doing the project for the course, your final project, where you might want to use an expression in the where clause that refers to something other than a primary key or a foreign key. And if that's true, you're going to have to know to go into Workbench and turn off safe mode in order to get your query to do what you'd like it to do. It is okay to turn it off. You just have to be prepared. If you make a mistake, you could change a lot of rows. So you can turn safe update mode off by going to the menu of Workbench and clicking Edit Preferences and clicking on the SQL Editor tab and changing the safe update option to turn it off and restarting your copy of Workbench. Okay? Just remember, it's a double-edged sword. It is a safety feature. You could accidentally wipe out a lot of data in your database. Now I'm just going to tell you this. You shouldn't be working with any database that you don't have a backup of. Okay? The sample databases that come with the book, we already know how to install those. We can just reinstall them, so we're okay. When you're working with your final project, you should be doing the same thing. You should, from time to time, you should be making a backup of the whole database. So if, in fact, you make a mistake and you severely damage the values in your database, well, then you ought to be able to go just as far back as your last backup and get started again. So don't be afraid to take it out of safe update mode once you get your sea legs. Okay, here on slide 15, how to update all the invoices for a vendor. So we're going to update a table invoices, set terms ID equals 1, where vendor ID equal, and now we have a subquery. Select vendor ID from vendors where vendor name equals Pacific Bell. Okay? So, why did we do it like this? Well, perhaps we didn't already know, or we didn't want to have to look up that the vendor ID for Pacific Bell. Or perhaps there's more than one vendor named Pacific Bell. I hope there aren't. But if the vendor name is not forced to be unique, that could be true. Let's hope that it's not that. Okay, in the second example here, update the terms for all invoices for vendors in 3 states. So we're going to update invoices, set terms ID equal 1, where vendor ID in, and then we select the vendor IDs from the vendors where the vendor state is in the list of those 3 state codes. And there we picked up 40 rows. So pretty neat. Okay, so if you are going to be doing proper functions on your database, you need to be able to insert, you need to be able to update, you need to be able to delete. Okay, now why would we want to delete a row? Well, a couple things can happen. One is we could realize that we made a mistake, that we, the users of the system, put some data in, and we were just simply mistaken. We thought we had a new customer, and then somebody said, oh, that's not a new customer. That's Harry's cousin. Okay, well, then we want to delete that row. Oops, we didn't mean that. Okay. Another thing can happen is that something that was true before is no longer true. Okay. So maybe we added Harry's cousin as a customer because we thought he was going to buy something. And then we find out that he's cheap and he's not going to buy anything at all. So we weren't mistaken, but certainly things have changed. So we want to delete that to reflect the fact that we have no expectation of Harry's cousin becoming a customer. The third situation is kind of tricky but very common, and that is there comes a time when rows in a table have kind of outlived their usefulness. And a typical situation is when, say, we have an invoice that's been paid and maybe it's over a year old. Okay, do we want to keep that detail in the current set of tables forever? No, usually not. What most designers do is they have some kind of invoice archive, and on some regular basis, they take a look at, say, the invoices, and they say, well, is it time to put them into the archive? So we've already seen the kind of statements that we need to get them into an archive table. Well, then we have to delete the rows that just went into the archive table because we don't want them in 2 places. So those are your use cases for a delete. So the syntax diagram is up at the top, delete from a table name, and then we have a where clause, so it's pretty simple. So the first example here, delete from general ledger accounts where account number equals 306. So account number is the primary key of that table, so we just get 1 row because they had to be unique. Delete 1 row using a compound condition in the where clause. So delete from invoice line items where invoice ID equals 78 and invoice sequence equal 2. Okay, so I'm guessing here, and I kind of remember probably the ID of an invoice line item is a combination of invoice ID and invoice sequence. Okay. We can delete multiple rows. So delete from invoice line items where invoice ID equal 12. So in invoice line items, one of the reasons that we have the table is to allow us to have more than one line on a particular invoice. We would like people to be able to buy more than one thing in a transaction. So if they bought 3 things in invoice 12, well, let's say 4 things here because 4 rows were affected. If they bought 4 things, then there are going to be 4 invoice line items that correspond to the invoice number 12, and here we can see that we deleted all 4 of them. And subqueries, which again we're going to learn more about in a subsequent chapter, we can have them in the where clause, and that becomes very powerful. So delete from invoice line items where invoice ID is in, and then we say select invoice ID from invoices where vendor ID equals 115. So maybe what's happened is maybe we get to the point where we're not doing business with a vendor anymore, and so we want to get rid of the vendors and all of the invoices, and probably, I mean, we're not checking to make sure that those invoices are paid, but probably if we are retiring all the line items, we probably know implicitly that the invoices are already paid. Warning, if you turn safe update mode off, MySQL Workbench will in Workbench and omit the where clause from a delete statement. All the rows in the table will be deleted. So you don't want to turn that off before you have your sea legs. Okay, because you can do a lot of damage, but I can't emphasize enough, if you do damage on our sample databases, you're just going to have to back up. If you do that, you'll restore the databases, and then you'll probably have to do a couple of queries before this one to get it in the same condition, but you can back up and you can recover. Okay? All right, so then that's it. So these functions of the database are typically referred to, the ones that we have learned about already are typically called the CRUD functions. Create, retrieve, update, delete. So retrieve, we already knew how to do because we had 2 chapters on the select. The create, the update, and the delete are insert, update, and delete. So now, having finished this chapter, we know how to do all the basic CRUD functions on a relational database. So go have fun with your exercises, and I'll say bye until next time. Bye-bye.